You're listening to DTFHN from March 25th, 2026. I'm your provenance unverified host, Jack Haxman. We are your daily tech feed for Hacker News, a website where links arrive with unknown motives and the upvotes tell the tale. The scaffolding we built our certainties on is showing its age. Let's run it. There is a particular flavor of absurdity that only exists right now, in this moment of history. And I want to sit with it for a second. A person. A biological human, carbon-based, grew up, has memories, has an aunt. Tried to convince that aunt they want an AI, and failed. Let that land. We spent decades worrying about the Turing test. Could a machine fool a human into thinking it was a person? That was the benchmark. That was the threshold. And somewhere in the last 2 or 3 years, we quietly crossed a different threshold that nobody put on the calendar. Humans are now failing reverse Turing tests, not because we've changed, because the patterns have converged enough that the category itself is breaking down. This isn't a story about one confused aunt. This is a story about the collapse of a heuristic that civilization has relied on forever. The assumption that you can tell intuitively whether you're talking to a person or a machine. That assumption is gone. Not weakened, gone. And here's the thing that actually interests me. The failure mode isn't that the aunt was fooled by something that seemed too smooth, too perfect. If anything, it's probably the opposite. She saw something that seemed a little too on point, a little too articulate, a little too whatever. And her brain pattern matched to AI, which means we've now trained ourselves to suspect competence, to distrust fluency, to read clarity as a red flag. Run that forward. What does a world look like where humans start performing incompetence to seem more human? Where you misspell things on purpose, hedge unnecessarily, introduce friction into your communication. As proof of authenticity? That's a strange tax to put on human expression. The deeper issue isn't detection, it's trust infrastructure. We don't have good tools for verifiable human identity that don't also surveil the hell out of everyone. And every closed system offering solutions here is trying to become the gatekeeper of who counts as real. That's an enormous amount of power to hand to really his power to any single entity. The tools exist to build this differently. Cryptographic attestation, decentralized identity, open protocols. The knowledge is available. The question, as always, is whether we build the infrastructure that distributes trust, or let it concentrate in the hands of whoever moves fastest. Your aunt is not the problem. The missing public infrastructure is. Moving on. $375 million. That's the number a cart put on what Meta owed for misleading users about how it protects children on its platform. Here's what makes this story more than a headline find. It's about what happens when you build a closed system, optimize it for engagement, and then tell regulators and parents that safety is a priority. The gap between those two things is where $375 million lie. The core of the case is that Meta made representations about child safety features and parental controls that didn't match what the platform was actually doing. The recommendation systems, the algorithmic feeds, the default. They were tuned for time, on app, and the people harmed by that gap were, in many cases, kids. What's worth sitting with here is the architecture problem when a platform is closed. When no external researcher can audit the recommendation engine, when no regulator can inspect what the objective function is actually optimizing for. The only accountability mechanism left is litigation after the fact. You find out what the system was doing by watching what it did to people, then arguing about it in court for years. That's an expensive and slow feedback loop. And $375 million for a company with Meta's margins is a rounding error on a bad quarter. the deterrence math doesn't close. The deeper question isn't whether Meta should pay. It's whether a fine is the right instrument at all when the underlying problem is opacity. You can fine a closed system and leave the closure intact. The same recommendation engine keeps running. The same defaults stay in place. The check gets written and the architecture doesn't change. Compare that to a world where the algorithmic systems that touch children are auditable. Not fully public, but inspectable by qualified researchers and regulators in real time. Not in discovery 5 years after harm accumulates. That world is technically achievable. It's a policy choice not to build it. Meta will appeal, probably settle for less, and the next platform will make similar calculations. Until the cost of opacity exceeds the cost of transparency, the incentive structure doesn't shift. $375 million, says the jury noticed. Whether the architecture notices is a different question. Moving on. Here's what compression actually means in practice. A model trained on hundreds of thousands of GPU hours, representing billions of dollars of compute. And someone figures out how to run it on hardware you already own. That's not a footnote. That's a redistribution of capability. TurboQuant is working in the space of extreme quantization. The art of taking a neural network that expects 16 or 32 bits of precision per weight and asking, what if we used 4? What if we used 2? What if we pushed to the edge of 1? The conventional wisdom says quality collapses. The interesting research asks where exactly that cliff is, and whether you can build a path that hugs the edge without going over. The efficiency gains here aren't incremental. We're talking about model sizes that shrink by factors of 8/16. Running inference at a fraction of the power, on a fraction of the silicon. A model that required a data center server can run on a laptop. A model that required a laptop can run on a phone. Run this forward. The threshold for can I use this keeps dropping, and every time it drops, a new class of people gets access. This matters beyond convenience. When capable models require expensive cloud infrastructure, there's a choke point. Whoever owns the infrastructure owns the access. Extreme compression dissolves that choke point. The model lives on your device, runs on your hardware, answers to you. The off switch is yours. The technical challenge is real. Quantization-aware training, calibration datasets, the specific ways different architectures respond to reduced precision. This is genuinely hard work. What makes research like TurboQuant interesting is the combination of ambition and rigor. Not just we compressed it, but we compressed it this far, and here's how we held the quality together. The tools exist. The knowledge is becoming available. Every paper like this one puts another rung on the ladder. And unlike the gatekeepers who stand on the ladder telling everyone else to climb, the researchers publishing this work are building new ladders and leaving them where anyone can reach them. Efficiency research doesn't always get the spotlight. It should, making powerful things smaller, faster, cheaper to run. That's not optimization for its own sake. That's how capability spreads. That's how the next person who needs a powerful language model finds one already in their pocket. So we're spreading capability, putting powerful tools in everyone's hands. Story 4 asks, what happens when someone decides those hands shouldn't hold secret? BOS never really died. It just went underground. Kept alive in the memory of every developer who used it in the late 90s, and couldn't quite believe what a desktop operating system could feel like. Snappy, responsive, architected around the idea that your computer should feel like it was actually built for you, not built for a committee. Vitruvian OS is the latest attempt to bring that energy back, and it's worth paying attention to. The name is a tell, Vitruvius, the Roman architect who wrote about proportion, harmony, function, serving form. The same ideal Leonardo sketched into that famous drawing of a man inscribed in a circle. The message is right there in the title. This is a project that cares about design as a first principle, not an afterthought. BOS had a lot of things going for it that we spent 30 years slowly reinventing. Its file system had metadata built in from the ground up. You could query your files like a database. Its GUI ran on a separate kernel thread from the application logic, which meant the interface stayed responsive even when your app was melting down. It treated multi-threading not as a feature, but as a fundamental assumption. By the time the rest of the computing world caught up to those ideas, B-Ink was already gone. What's exciting about Vitruvian O isn't nostalgia. It's the question of what you build when you start from those principles on modern hardware. Linux as the foundation gives you 30 years of driver support, a massive ecosystem, actual security maintenance, BOS aesthetics and design philosophy as the superstructure gives you something that most Linux desktops simply don't prioritize: coherence, the sense that everything belongs together. Desktop Linux has always been technically impressive and ergonomically scattered. Dozens of environments, each with their own conventions, their own rough edges, their own half-finished corners. Vitruvian OS is making a bet that opinionated design, real design with a point of view, is what's been missing. The tools are open, the source is available. Someone looked at what was lost when BOS died and decided to rebuild it on ground the community actually owns. That's the whole story of how open source accumulates quality over time. Not always through committee, but through individuals with taste who refurbish you to let good ideas disappear. Story 5 is a different kind of open source. Human wonder recorded and shared. Let's go to the stars. Sora is gone, or going, or already a ghost. The details depend on when you're hearing this, but the shape of the story is clear enough. OpenAI's video generation flagship, the model that dropped Jaws in February 2024 with its minute-long cinematic hallucinations, is being wound down for a product that arrived with so much fanfare. The boardroom drama, the safety debates, the Altman on stage moment. It's a quiet exit. Here's what's worth sitting with. Sora was never really a product. It was a demonstration, a proof that diffusion and transformer architectures scaled far enough could learn the physics of light and motion well enough to fake them convincingly. That was genuinely remarkable. The research was real. The capability was real. But real capability and durable product are different things, and the gap between them is where a lot of AI companies are currently living. The honest red is that the video generation market moved faster than OpenAI anticipated, while Sora was in limited access. Drip release to creators, carefully managed, the off switch firmly in OpenAI's hands. The open source community was running OneVideo, Cogvideo X, Hunya, models you can download, run locally, fine-tune on your own data. Modify without asking permission. The capability delta closed faster than a closed model can iterate when it's balancing safety theater with commercial pressure. This is the pattern. When a capability is genuinely useful, open systems catch up. And when they do, the closed system's only remaining advantage is brand and access control, neither of which is a moat. What Sora leaves behind is more interesting than Sora itself. Every researcher who watched those early clips and thought, I need to understand how this works, went and figured it out. The papers got written. The architectures got published. the knowledge propagated. Sora may be shutting down, but the thing Sora represented. That video generation at this quality is possible. That's permanent now. The tools exist. The knowledge is available. And, increasingly, the compute is getting there too. OpenAI built something that mattered, demonstrated it, and then handed the lesson to everyone who was paying attention. Whether that was the plan or not, the outcome is the same. The interesting thing about closed systems is that they're often the best advertisement for open ones. From understanding how systems fail to understanding how soil does, pause, story 6. And someone looks at Unity. Unity's co-Rusin system is old. It's a C in a cur, wrapped in a scheduler. You write a function that yields, the engine resumes at next frame, and you get this beautiful illusion of sequential logic spread across time. Start a fade, yield for 2 seconds. Play a sound, yield until some condition is true. It reads like a story. The underlying machinery is a state machine the compiler builds for you, invisible, handling all the "where was I" bookkeeping automatically. Now here's the insight. C++ coroutines are doing the exact same thing. The difference is that C++ hands you the machinery and says, configure this. The coroutine frame, the promise type, the awaitable protocol. All of it is the engine that Unity hid from you. Unity said, trust us, we'll run this. C++ says, here are the gears. Build whatever engine you need. That sounds like a drawback until you realize what it buys you. You can write coroutines that yield to a thread pool, to an async I/O system, to a game engine, yes, but also to a network stack, a database driver, a custom scheduler for embedded systems where you control every microsecond. The abstraction is programmable because the use cases are genuinely diverse in ways that a game engine doesn't have to care about. The title of this article is doing something I love, using a familiar, concrete system to illuminate an abstract, general one. Unity is millions of developers' first encounter with cooperative multitasking. The coroutines feel magical because Unity handles everything downstream of the yield. C++ 20 coroutines feel bewildering because you're suddenly responsible for everything Unity was handling silently. Once you see that, the design makes sense. The complexity isn't accidental. It's the cost of generality, of building a primitive powerful enough that game engines, async runtimes, and operating systems can all sit on top of it. The tools exist. The knowledge is available. Sometimes it just takes the right analogy to make it click. Moving on! There's a particular kind of anxiety that lives in airports. You are in a metal tube that will soon be launched through the atmosphere at 500 miles an hour, and your entire relationship with that fact is mediated by a departure board and whatever the gate agent decides to tell you. For most of aviation history, the information asymmetry was staggering. The airline knew everything. The passenger knew almost nothing. And the gap between those two states was measured in stress. Blighty has been quietly closing that gap for a few years now. The app built its reputation on surfacing data that used to live only inside airline operations systems. Gate changes before the board updates, delay probabilities before the delay is official, push notifications that feel almost precognitive. People who travel frequently treat it less like an app and more like a translator. It converts airline opacity into something legible. Flighty Airports takes that same logic and applies it to the physical space itself. The airport as an object of knowledge, not just a waypoint. Which security lanes are moving? Where your gate actually is relative to where you land. The texture of a connection you've never made before. Rendered navigable before, you're standing in it confused with 17 minutes on the clock. This is genuinely useful, and the fact that it exists is worth pausing on. The data was always there. Airports generate enormous amounts of operational information continuously. What was missing was the layer that made it accessible, organized, and pushed to the person who actually needs it, at the moment they need it. That's the whole game. Not collecting data, but making it actionable for the individual rather than hoarding it for the institution. Run this forward and you start to see what the travel experience could look like when the information flows to the traveler instead of around them. Misconnections become rarer, not because flights get faster, but because people have better situational awareness. The airport stops being a place where things happen to you and starts being a place you navigate with actual agency. The tools exist, the data exists. Someone just has to decide that the passenger deserves to see it. Flighty keeps deciding, yes, that's worth celebrating. From giving travelers agency to giving builders total control. So to pause, Story 8 is someone who built their own processor and then ran a first-person shooter on. 16 years is a long time in software years. Video.js launched in 2010, back when HTML5 video was a battleground, when Flash was still clinging to relevance, when getting a video to play consistently across browsers required a minor miracle and a prayer. The library solved a real problem. It spread everywhere. And then it did what successful open source projects often do. It accumulated features, abstractions, compatibility, shims, for browsers that haven't existed in a decade. Technical debt that nobody wanted to touch, because touching it meant owning it. Then someone took it back. That framing matters. Took back implies it had drifted away from something. From its original purpose, from community control, from the kind of lean intentionality that makes a tool genuinely useful. The person behind the Show HN post isn't just a contributor who submitted a PR. They reasserted stewardship. They looked at 16 years of accumulated mass and made a decision. We're starting from what this thing actually needs to do. The result is 88% smaller. Let that land for a second. Not a 10% trim, not a refactor that shaves some bytes. 88%. That means the original code base was carrying roughly 8 times more weight than the problem actually requires. Some of that is legitimate evolution. The web changed, use cases expanded, but most of it is the slow entropy of software that nobody has incentive to simplify because simplification doesn't ship features. What does 88% smaller mean in practice? It means the library loads faster. It means there's less surface area for bugs. It means a developer reading the source code can actually understand it, which is the precondition for trusting it, extending it, contributing to it. Readable code is collaborative code. Bloated code is a moat. This is also a story about what open source makes possible. A proprietary video player with 16 years of enterprise customers doesn't get to do a ground-up rewrite. The incentive structure won't allow it. You can't call your paying customers and say, we threw it out and started over. Open source projects can do exactly that. Because the license is a contract, not the vendor relationship. The community can always fork, rethink, rebuild. Someone did, the tools existed, the knowledge was available. They just had to pick them up. That's the whole story, honestly. That's how this works. What happens when the law catches up with open infrastructure? Story 9 is a win worth knowing about. There's a beautiful irony buried in the history of electrical power, and data centers are finally cashing it in. In the 1880s, Thomas Edison lost. He backed direct current. DC. And George Westinghouse, with Nikola Tesla's alternating current patents, handed him one of the most decisive defeats in the history of technology. AC could travel hundreds of miles without significant loss. DC couldn't. So the grid became AC, and Edison's vision became a footnote. Here's the twist. Everything inside a modern data center runs on DC. Every server, every switch, every storage array. DC, the power coming in from the grid, is AC. For over a century, data centers have been doing this conversion dance. AC comes in, gets stepped down, gets converted to DC, flows into the server, gets converted again at the board level. Every conversion loses energy as heat. You build a facility, and then you spend a meaningful fraction of your power budget just fighting your own electrical infrastructure. The transition back to DC distribution is the industry finally admitting the obvious. If your load is DC and your generation is increasingly DC. Solar panels produce DC, batteries store DC. Why are you introducing AC as an intermediate step at all? You're not. Not anymore, not in the facilities being designed today. The efficiency gains are real. Fewer conversion stages means fewer losses. In a hyperscale facility drawing hundreds of megawatts, even a 2 or 3% improvement in power usage, effectiveness, translates to serious money and serious carbon. And the integration story with renewables gets dramatically simpler. A DC bus that connects directly to solar and battery storage without round-tripping through an inverter is just a cleaner architecture. There's also a reliability angle. Fewer components in the power chain means fewer failure points. AC to DC conversion hardware fails. Eliminate the conversion. Eliminate the failure mode. Edison was wrong about transmission. The physics of the late 19th century made AC the only viable choice for moving power across distances. But he wasn't wrong about what's useful at the point of consumption. The grid stayed AC because that problem isn't solved. The data center went DC because that problem is. 140 years later, the revenge isn't dramatic. It's just good engineering catching up to what the load always wanted. 10 stories in, and we have covered engineering wins and engineering stubbornness in equal measure. Story 10 lands firmly in the second category. Two versions of light L. 一点白冷千赞的寒宽的跨大游艇总理点排了什么入 were pulled from PyPy after being flagged as compromised. If you've been anywhere near the AI tooling ecosystem in the last year, you know LM. It's the unified interface layer that lets you swap between OpenAI, Anthropic, Gemini, and a dozen other providers without rewriting your application. It's everywhere. That's exactly why this matters. Supply chain attacks are the patient predator of the security world. You don't break down the front door. You slip something into the package that ships through the front door. The target isn't a single company or a single developer. It's every downstream project that runs pip install and trusts that the version number they got is the version the maintainers actually built. We don't yet have full public disclosure on what exactly the compromised packages contained. That's worth saying plainly. The details are still emerging. What we know is that the packages on PyPI didn't match what they were supposed to be, and that's enough to treat any environment that installed those two versions as potentially hostile until proven otherwise. Here's the practical thread to pull. If you're running light LLM in production, then an AI pipeline, an agent harness, a routing layer. Check your installed version immediately. If you're on 1.82.7 or 1.82.8, rotate your API keys. All of them. LightLM sits directly in the path of every API call you make to every model provider. A compromised version at that layer has access to everything flowing through it. The broader implication is one the Python community has been wrestling with for years. PyPI is open infrastructure. That's its strength and its exposure surface. The package namespace is not cryptographically bound to the repository in a way that prevents this class of attack. Projects like SigStore and PEP740 are working on provenance attestation, trying to create a chain of custody from source code to published artifact. That work matters. This incident is another data point in the argument for it. The maintainers responded, the packages were pulled, the community flagged it. That's the open source immune system doing its job. Imperfectly, with some blast radius, but functioning. Check your dependencies, rotate your keys, and watch for the post-mortem, because the technical details of how this happened are worth understanding. This has been your daily tech feed for Hacker News for March 25th, 2026. This podcast is entirely AI-generated. Scripts by Claude Opus 4.6. Voice by Quinn3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that belongs to everyone. We'll see you back here tomorrow.